Hello everybody, so today I thought I'd give a crack at reviewing one of the old AP Physics 1 FRQs. This one's from the 2015 exam and it has to do with the Atwood machine and Newton's second law. I've seen this problem a couple times before. Pretty interesting, it all clicks at the end, it's quite satisfying, so this one's actually quite fun to do. But yeah, let's get right into it. So, oops, another weird mark. So let's just read the problem real quick. So, two blocks are connected by a string of negligible mass, nice to know, that passes over massless pulleys that turn with negligible friction as shown in the figure above. That's quite nice because if there was friction, we would have to account for that when calculating, say, like the acceleration of the system, which we will have to do later. But the mass m2 of block 2 is greater than the mass m1 of block 1. That's kind of hard to say. The blocks are released from rest. Okay, so first thing that we need to know is that this mass right here is greater than the mass of block 1. So it wants us to draw the free body diagrams now, labeling the forces, okay, not the components, and we want to draw the relative lengths as well to reflect the magnitudes. So let's just start with both block 1 and block 2. What is something that's always going to be exerted on them is going to be the force of gravity. And it also looks like there's nothing acting in the x direction here. At least individually on the blocks. So it's only going to be in the y direction. So block 1, it's going to have the force of gravity. Let's just call it FG1. And since block 2 is greater and FG is equivalent, so FG is equivalent to m times g. If you have a greater mass, then you can have a greater FG if the gravitational constant is the same. We're assuming that, these two blocks are on the same planet unless there's like a alternate dimension between the two, which probably isn't the case. But yeah, that's gonna be, let's just have that be nice and long there. So let's call that FG2. And now what is the other force acting on it? Well, there's something that's pulling above, right? And that's gonna be this pulley system right here. And so that string is gonna represent the force of tension. And that's actually gonna be the same. It's gonna be the same in terms of magnitude between the two because both blocks affect the same string and they're connected by the same string. And so when we actually go to calculate the sum of the forces, that just cancels out each other because you can have something in the positive, something in the negative, and so it's all zero at the end. So let's just draw that somewhere in the middle in between and call that FT1, FT2. I think I can label it differently. They just have the same magnitudes. All right, let's move on. So it wants us to derive the magnitude of the acceleration of block 2. Express your answer in terms of those things. Okay, so as I said before, this is a Newton's second law problem. So let's just write out Newton's second law and see where we can go from there. Sum of the forces is equivalent to m times a. So already looking at this problem now, we want to isolate and find the acceleration, right? But the acceleration of block 2. I think a quite simple way to think about this is the acceleration of the system. Because since block 2 is greater in mass, the entire system is obviously going to accelerate towards that side. And because of that, block 1 is acting sort of taking away as the negative, and block 2 is sort of like the positive. Okay? And so when you observe the entire system where you have a positive and a negative, you can account for that as a system. And so the acceleration of, say, block A is really just the acceleration of the system, right? Because block A is connected to the system, and because it's in free fall and because it's an Atwood machine, that is going to hold true. And so because of that, that makes everything else quite simple to do now that we already have the forces, because we already drew the forces here. And we can transfer that over to the sum of the forces in the system is equivalent to the total mass of the system times the acceleration of the system. And we know we want to find the acceleration of block 2, and the acceleration of block 2, block 2 is equivalent to the acceleration of the system. So first, let's just take a look at the sum of all the forces. I'm going to change colors for this. Let's use like a light green. I like this color for some reason. Okay, so the sum of the forces in the system is going to be just FG, because as we talked about before, the force of tensions just cancel out each other. And so since block 2 is acting in the positive, it's heavier, so its Fg is going to be greater. Let's just call that the positive force. So we have Fg, Fg is just m times g, and so we can just write this as m2 times g, and we're going to be subtracting this thing, which is acting in the negative, m1 times g, and that is going to give us, I'm just going to write ma, but that's the same thing as this. I'm just transferring over. And to simplify this even more, it's just m2 times 1 minus g equals ma. So that's just this distributive property. Makes it a little cleaner to look at. And now we want to look at the entire mass of the system, right? In the entire mass of the system, what two masses are accounted for? Well, we know that the pulleys, the string, everything, it's stated that it's negligible mass. And so the two blocks that are affecting the entire system is going to be block 2 and block 1. So we can just add the masses together. So let's just rewrite this as m2 minus m1, g equals the mass of m2 plus m1 is equivalent to the acceleration. So we want to find acceleration, so we can just divide this by m2 plus m1. And we'll get m2 minus m1 times g over m2 plus m1 is equivalent to the acceleration of the system, or as we talked about before, block 2. And that's our answer for this problem right here. All right, let's move on. So it looks like block 3 of mass m3 is added to the system. So they clearly indicate it's a system. As shown below, there is no friction between block 3 and the table. That's nice to know, because if there was friction, it would slow down the acceleration even more, and we would have to account for the force of friction, which is kind of annoying. But let's look at what the problem is actually asking. So it says indicate whether the magnitude of the acceleration on block 2 is now larger, smaller, or the same as the original 2-block system. So if you were actually doing this problem, you would probably have to give a written explanation. But I'm just going to transfer this equation we had before, and let's just look at it in its components, and I think it would make a lot of sense. So m2 minus m1 times g, this entire thing over m2 plus m1 equals the acceleration of block 2. And I'm also going to write Newton's second law. So let's look at this problem. So if you were to add another block to the entire system, what would actually change about the system, right? If block 3 was like out here, it would be accounted for in the net force. However, it's not accounted for in the sum of all the forces. Fg is not affecting the acceleration. Instead, only the mass is affecting the acceleration. And so we can write this as, if you'll let me write. So we can write this as, I'm going to change colors for this. Let's use this blue color. So we would have m2 minus m1 g, right? Because anything internally is just non-negligible, and the mass 2 and mass 1 stay the same. This one's acting in the positive, and this one's mitigating it. And so that is going to be the same. The net force will remain the same. However, when we divide, right, when we isolate for A, this mass, this total mass is the system's mass. And did the system's mass change? Well, it did, because we literally added this additional block. So we're going to have m3 plus m2 plus m1 is equivalent to the new acceleration. Now, does that new acceleration decrease, increase, or stay the same? Well, presumably mass 3 holds some mass, a positive number. And so let's just say we had an arbitrary number on the top, let's say 1. And our original one, our total mass, this is just out there, let's say it was 2. So that would be our acceleration. So if you were just to add, let's say mass 3 was 0.1. So then we have 2.1. Well, let's see which one is greater. Well, oops. So 1/2 is obviously greater than 1 over 2.1. And so because of that, the magnitude of the acceleration is now smaller. All right, that should do it for this video. Hope you guys learned something. And yeah, if you have any other questions, drop a comment. Thank you for watching.